Here are another few rules about functions and returning. If your function is of type void, void means that this is just a plain function which doesn't do the two birds at one stone. It doesn't do some stuff and also return a value. This type of function just does stuff and does not do the other part of returning something. So this function right over here will just start doing all of the instructions it was given, and then when it reaches the closing brace, that's when it stops and it goes back to wherever it was called from. Since nothing is being returned, it is not considered an expression, so you can't like try to assign what comes out of function 1 to a variable x, for example, because nothing comes out of the function 1. Function 1 returns void, which means nothing is coming out of it, nothing is being expressed from this function 1. However, the word return does mean two different things. At one point it means ending a function and going back to where we came from, and it also means bringing back some stuff like a value or an expression along the way. So about the going back to where we came from, you can use the word return in a void function. So this will basically tell the function that now it's time to go back to where we came from, and just put the semicolon right there without returning a specific value or number, because this function doesn't return anything. As a matter of fact, if you try to return something, you will get a compiler error because you declared this function will not be returning anything. So make sure that you only type return and leave it blank. But this is pretty implicit, so you can just leave it out, because just the closing brace right over there is just as good as typing return with a semicolon. Now, on the other hand, a function which will return something, like this function over here which will return an integer number, this function must have a return statement at some point which returns a actual integer number. If you leave this function without the return statement, or you have the return statement without anything being returned, you will get a compiler error. A function which you declared will return something must actually return something. And then of course you could take advantage of that stuff which is being returned and use that as an expression to assign it to some different variable, etc., etc. Another thing is that any code which is typed after the return statement will always be ignored when the return statement is encountered. So if I type a whole bunch of code right after the return statement, all of this is useless because it's never going to be done. As soon as we reach the return statement, we jump right away to the closing brace and we go back to where we came from, and this stuff is never going to be done. So again, here we see the two birds at one stone effect. At one hand, what we're saying over here is we'd like to stop right here, the function, and go back to where we came from, and therefore none of this is going to be done because we're skipping ahead. We're going right away back to where we came from. And of course, at the same time, we are bringing along the way some value, some sort of expression, which will be expressed in the calling function. Here's another useful thing about return statements. You can have a couple of them actually in your function, and you can decide which one should be reached depending on some condition. So you could like evaluate if x is more than 10, then we will return this stuff over here. And if this is actually done, if x is actually more than 10, then anything after this return statement will be ignored, and we're going to go right away back to where we came from. However, this is false, then this is totally ignored, and we evaluate the next expression, the next if statement, and maybe this one will be executed. However, when doing this, make sure that at some point every single possibility is covered, because we don't want to end up in a situation where this was false and this was false, and we end up having a function which must return a value, and in the end it doesn't because we didn't think about every possibility of the conditions which make it return something. So there you have it. Functions is a very powerful, fun thing to play around with. So like if until now you've been doing stuff by typing instructions over and over and over again, what you can do now is just take one set of these instructions, put them all in a function, and then all you gotta do is just call the function again and again and again, and you'll have that whole list of stuff being taken care of automatically without the need for you typing over all those instructions again and again. So it's like a shortcut pretty much. You can call that function as many times as you like. Okay, enough about functions for now. Let's move on to some basic very important rules in C++. As an introduction, here's some other feature of C++. You can use blocks of code to organize any piece of code you'd like in this neat little way. A block of code is a bunch of commands of C++ code which are enveloped inside of an opening and closing brace. So as you noticed, of course, a function has its own block of code, which is the actual code of the function that it does. But even inside of a function you can have a small, like a little sub-function, which is just really a neat way of organizing code if you want to like wrap it up in a little package. After that said, we're going to learn about the rules of scope and visibility. The rules of scope are like this. Any variable that you create is limited, it has limited lifetime to the code block where it was created. Meaning that this variable x right over here is limited to the code block of the main function, which a code block again starts with the opening brace and ends with a closing brace. So this is the world in which the variable x lives. Once we leave this world over here, the variable x will disappear, it'll be destroyed basically. Anything enveloped inside of a code block will be limited to that code block. So if I have, for example, an if statement, and if I have an if statement and I decide not to do the inline action, I decide to use the code block feature so that I can do a whole bunch of stuff if the expression is true. If I create a variable inside over here, this variable right here will be limited to the lifetime of this scope, this little piece of scope right over here. So as long as we are inside this scope, I could do anything I want with this variable y. I could give it 10, I could increment it, I could do whatever I want. But once we leave this scope over here, because this variable was created inside of a inner bubble, a inner world, or in C++ a inner scope, that variable does not exist anymore. So if I try to use it later on, I will get a strict compiler error because I never created this variable y. Oh, but I did create it. I created it right over here. Yeah, well, that was in that world when that little scope existed. But we're out of that world right now, and anything in that world was destroyed. So the variable y does not exist anymore. Since we are still in the world of the main function, the variable x still exists. That's still in our world. As a matter of fact, if we are in this smaller world over here, the variable x also still exists, because even though we are inside a smaller world, but that smaller world is inside a bigger world. So since we created the integer x in the bigger world, then as long as the bigger world exists, so does this variable, which was created strictly in that outer world. So I could still use the variable x in the smaller world, in the bigger world, because we are still inside of the world of his scope. So again, basically the rules of scope is that anything inside of braces, and of course in C++ everything is inside of braces because everything is happening inside of functions, whether it's the main function or other functions. So everything being created, again being created specifically inside of a certain scope, has limited lifetime to live as long as that scope exists. So any variables inside of other functions, etc., are also limited to their little world of that function. So I can't be using the variable j inside of my main function because that variable j is in the world of that function. It's not in the main world function. And I can't use the variable x in this function over here because variable x exists in the world of main. It doesn't exist in the world of this function over here. Everyone belongs to the world where they were created. Like this variable over here, which was created inside of a local scope, even if it wasn't an if statement, just a little code block just like that, well, this variable y will get destroyed as soon as this scope is finished.